6th. Bryce, you ready for Christmas?
Yeah.
You got all your Christmas? Did you get all your Christmas shopping done?
No. My parents are letting the kids buy for going on a vacation.
Go, you'll be in Florida during Christmas. That's
We
nice.
leave on
We did that a couple of years ago. We were in California, went to Los Angeles and dinked around for 5 days. It was
We're going
nice.
up to Miami. On Christmas.
Nice. That's new and different, huh? Go swimming and then go play a round of golf on Christmas Day. You a golfer?
Sometimes.
All right. Cool. Yeah, today you meet the third guy. His name is Point Slope Form. It's super nice. Oh, is it nice? Ooh, it's probably my favorite just because of the um you'll hear me use this expression again, the foot in the door. A big thing that we're going to embark on here starting after today is learning the art of writing equations of lines under different scenarios. And so the point slope form is always going to allow us, you'll know more what I mean in a couple of days, but it allows us to hop in and boom, just with the snap of a finger, have the equation of a line. And then you can do with the point slope form whatever you want. So I'm going to pause this and change my attendance real quick. So point slope form. I'm just going to put it up here and you're going to look at it and think something probably like, oh my God, what is that? But it's actually super nice. So this is the format for point slope form. It looks weird, huh? Not too bad. Those little numbers down below are called subscripts. They're not anything mathematical. They're just labels that we use to differentiate between y and another y. So math people decided long ago that if we put, you've seen it before, like you saw it with the slope formula, right? Y2 minus y1. By labeling things with subscripts, we can give it, we can say, hey, you're a y coordinate, but you're the different one than this y coordinate. So don't think that the little one underneath has any mathematical relevance. It's just a label for us. All right. And so we're going to show you how easy this can be. But first, we're going to label some stuff. We're going to go in and kind of make sense of what this is. This equation has three inputs. There are three places where we put things, put information that we have. And the y coordinate. So I'm going to write all this down with you. So I'll try to be nice and neat for you. I'll switch to my thinner pen so I can be neater. So your y coordinate goes there in place of y sub 1. And as you might suspect, the variable that's labeled x sub 1 or x1 if you choose, that's where the x coordinate goes. And there's one more character in this equation that you're very familiar with. Who is it? Of course. You've seen m before. Which I tried to get that into you, and I know Mr. Manlove did as well, that when we see m, generally lowercase m, we're referring to the slope of a line. So the last input is right here. And the slope goes here. So you'll notice that the regular y and the regular x do not have inputs. That's by design. All right. It's no really great way to explain why or how this is, but those two stay put. And then as we put numbers in place of y1, x1, and m, then an equation takes form. And then I say after that, you'll see we can do whatever we want. We probably won't do much manipulation today. Like in the assignment, your inputs can just go in as point slope form. They don't take long at all. It's very easy. So let's do an example. A common request will be write the equation of a line given this information. And so I might give you a line like this, and I might say, okay, this line has a slope of 1/2, and it passes through the point 4, 5. Now, for the record, if I had no idea what point slope form was, I could, and I don't think you should write down what I'm about to do because it's silly, but I could graph the point 4, 5. This is not what you're doing. I just want to show you that in a panic moment, like let's say you're on the ACT, there's nothing stopping you from making a sketch. So like I could go to the actual point 4, 5. So I could go right 4, up 5, and make a dot, like right there, couldn't I? Say, okay, I got a line that goes through that point. And if the slope of the line is 1/2, then I could go down 1, left 2, down 1, left 2. And then you see that I could actually make a prediction about what the equation of the line would be. I could. And if I had graph paper, it would be really, really obvious, but I would easily now be able to identify that the equation of the line is obviously y equals 1/2 of x, because we know the slope is 1/2. And then can you guys predict for me? You're all pretty bright. Can you predict what that y-intercept actually is? Good job, +3. Because if I already was up 5, remember this point was up 5. If I go down 1 and down 1, now I'm up 3. Good job, Bryce. Excellent answer. So that's not an efficient way to write the equation of a line, right? But do bear in mind that that's always a possibility, not an attractive one, but a possibility. So if you would, do me a solid and jot this down, just the equation, because I want to come back to that in a second. I'll write it down over here. And now I'm going to erase a bunch of this stuff. All right, so let's mathematically do this the sensible way, the way that this lesson is intended to show you today. So I'm going to take that blue equation up in the corner of the TV there, and I'm going to put numbers in place of letters. So first things first, where the red writing is, where the y coordinate goes, I'm going to change the equation now, and it's going to say y minus what? What does it say goes in that y sub 1 spot? The y coordinate of the point. It says it in red writing right underneath. The y coordinate goes here. So what will I put in place of y1? What's the y coordinate of my point? Very good, Zane, 5. So I'm going to put y minus 5 equals. And then, of course, where it says m, well, that's easy. I'm going to put 1/2. And then I'm going to open a set of parentheses, and I'm going to put x minus, and what's going to go in place of the x coordinate? 4. Very good. Now, you might look at that and say, well, that's not what we got before. That thing that's in white down here in the corner, that's not the same. It can be the same. So what we're going to do now, just for fun, because you'll be doing a lot more of this in coming days, but I just thought I'd show you. I like to see when stuff is legit. You're like, wow, it actually works. I'm going to take my 1/2, and I'm going to distribute it through these parentheses like this. So I get y minus 5 equals, what's 1/2 times x? 1/2 x. And what's 1/2 times -4? Good job. And you see now that that blue equation, the one in the skinnier writing, is getting closer to looking like the white one across from it on the TV over there, huh? The only thing that's left is to get y by itself. And how could I get y by itself? I could add 5 to both sides like this. I could just put a little +5 here. You've done this about 927 times already, probably in the last 3 months, and then get rid of those, and presto, voila, take a look at this. You get y equals 1/2 of x. Aha, -2 + 5 + 3, jackpot. So you can see that's kind of neat. It actually works. You're not going to be asked to do all of these steps today. You're going to today get really good at this, just this. Writing the point slope form is what we're going to practice a lot today. So let's practice again. I'm going to give you some information, and you're going to write me the equation of the line. So this time we're going to have a slope of -2, and the line is going to pass through the point -3, 10. There's some of you have already probably figured out how easy this is, but for those of you that are looking at this and kind of thinking like, I don't know what he's talking about, just wait. Over the next couple of examples, you're going to say something to yourself like, is this seriously that easy? And I know in this line of work, I'm not supposed to say that word easy, but this really is easy. Once the light bulb comes on, easy. So I'm going to begin by writing y minus. And what am I going to do? Y minus what? 10. Very good. And then I'm going to put equals. And what am I going to put next? -2. And then I'm going to open a set of parentheses, and I'm going to put x minus what?
It would be -3.
So I would put very good. That's weird. I put x plus 3, but you've seen it before over and over again in math, that when you have to do minus, but the minus is immediately followed by a negative, then of course it becomes plus. So this is a good answer for today. There is my equation of the line. Boom, I type it in and I'm done. Let's practice again. Slope is 1. We're going to go through the point -2, -6. What is it going to look like? It's always going to go like this. Y minus. Start like that. What's it going to be? Y minus what?
Oh, it would be
Y plus 6, because it's really y minus -6. So I'll put plus 6. The minus is built into the formula. The minus is built in here, always. It's just a question of, will I change the minus to a plus? It's always the question. And what am I going to put next?
Equals x plus 2.
Nice job, Bryce. If that confuses you, there's nothing stopping you from putting this. But if I'm any good at algebra teaching, you've learned by now that putting ones in places like that is not wrong. It's just a little weird, right? So I love what you said, Bryce. Just leave it without the one because it serves no purpose. Everybody okay so far? Good, good? Okay. Now, this is the second half of the lesson, and it's a little bit harder, but not much. So this time, you can put this in your notes, something like, what if I'm only given two points? Now, based on the last 5 minutes of this class, I hope you can answer this question. What are the two things that we need to write the equation of a line? We need a point and a slope. Very good. We need a point and a slope. And I mean, that's pretty self-explanatory. It's point slope form, right? What don't we have here? oh, I don't have anything, of course. And so if I'm just, let's do an exam. I'm so sorry. I didn't actually finish my question. Let's say that the line goes through the point 2, 5 and 4, 4.
And what is the graph of it?
You could, and again, that goes back to the beginning of class today. Could I grab a piece of graph paper, graph the 2 points, look at the slope on the graph, and then try to, yes. But do I need graph paper to find the slope of a line? No. We've practiced this before. How do I find the slope if I'm just given 2 points? So what you're saying is, I need the slope, don't I? I need the slope. I'm not going anywhere without the slope. That's going to become a pretty popular theme here over the next week or so. You got to have the slope. If you don't have it, just go find it. You don't need a graph. So 4 minus 5 is going to go on top, and then 4 minus 2 is going to go on bottom. And you know how I feel about this. We show our work. What is 4 minus 5? -1. And what is 4 minus 2? So the slope is -1/2. This, I know from years and years of teaching, this particular type of problem can get to some people. It's confusing. But if you think about it now, take a step back and ask yourself, do I have a slope? I do. Do I have a point? I do. I actually have 2 of them, but I get to pick one. So let's say that I choose, well, obviously I have to use this as my slope. Which point do you guys like better, 2, 5 or 4, 4? Let's do 4, 4. So I'm going to use, for this problem, the 2 things that are in the yellow boxes. Inevitably, you're going to want to ask the following question. What happens if we pick the other point? You'll see. So what would my point slope equation be, what we're learning today, if we have a slope of -1/2 and we choose to use the point 4, 4? What would my equation say? Good. Now, let's say that someone else chose the green point. It's going to look different, isn't it? There's no way this is going to be the same answer. It's a load of baloney. So what would this point slope equation say if I chose the green point?
1 minus 5, -1/2.
Would you believe me, and you don't have to believe me just because I'm your math teacher, would you believe me if I told you that the green equation and the blue equation are exactly the same?
Yeah.
Let's find out. Let's do what we did earlier in the class. Remember when we took the point slope and we distributed and made it look like we like y equals mx plus b? This will reveal the truth of the matter. Are these the same equation or are they not? So let's take a moment now and let's do some basic math. Let's focus on the green side first. If I distribute -1/2 to x, what do I get? And if I distribute -1/2 to -2, what do I get? +1. And then I'm going to copy down my y minus 5. And what step do I have to do now to get y by itself? So I get y equals -1/2 of x. Nice job. So that one is sitting there like, okay, this is my true identity. You can see me now. You can see that to start me as a graph, you'd go up 6, put a dot, and then you'd go down 1, right 2. That's my identity. You can see me. Let's go do the blue one. If I distribute the -1/2 through the parentheses, what's -1/2 times x? I'm sorry, I'll quit making you answer that question. What's -1/2 times -4? +2. And what's the last step? And you get what? The moral of that story, if you're paying attention, is that it doesn't matter which point you pick in one of these scenarios. If you're doing it in a computer program like Delta Math, they'll both be counted correct if you don't make a mistake. Because as you can see, while up at the top of the TV, the green and the blue may look different, they're not. They actually represent the exact same line, which is pretty cool. All right. All right, let's practice that again. We're not, by the way, we're not going to go through all these steps again. We're just going to stop when we get to the point slope. So let's practice again. This time, I would like to use a slope. Oh, no, I don't want to do that. I would like to go through the points -2, 7, and 4, 1. So what's missing? So what are we going to do? We're going to find it. I could not have asked for two better answers than that. What's missing? The slope. What are we going to do? Find it. Cut and dry, clean and simple. You always need the slope. Slope's everything. So on top of my slope fraction, we'll go this subtraction problem right here. And that says 1 minus 7. On the bottom of my slope fraction, follow the blue arrow, we'll go, what problem is that? 4 plus 2. Very good, you guys. And then I got to know some third grade math here. What's 1 minus 7? Oh, don't you start with me. -6. And what's 4 plus 2? What's the slope? So the slope is -1. So that's my m. My slope is -1. As a class, which point do we elect to use? The first one or the second one? Probably the second one, just because you don't have to deal with the negative, the hassle of a negative. But as you now, I hope, understand, it wouldn't matter had we chosen the first one. But yeah, as far as path of least resistance is concerned, we'd probably choose the one like that, the yellow one. So what will my point slope answer say? And this is what you type in. Hit submit answer. Are you sure you want to submit this answer? Hit enter. And that's what you're doing today. You guys think you got this?
Yeah.
Rad. Okay, it should be on, it assigned itself on Delta a little bit ago. It's a mixed bag, by the way. Some of them I'll give you the slope and a point. Some of them I'll just give you 2 points. And so just luck of the draw, you get what you get. You don't throw a fit.